All right, boom. Welcome back to another video. Today we're gonna be practicing some SQL. So what we're doing is we're gonna do some Hackerrank SQL questions. So for this video, I'm thinking we're gonna do all of the basic SQL. So every single one of these questions. And then after that, we gradually in the next video we do the intermediate, and then in the next video we do the advanced. So let's start with the first one, which is revising the SQL query. Revising the select query one. So let's look into it. So we're supposed to query all columns for the American cities in the city table with the populations larger than 100,000. And the country code for America is USA. So query all columns for the American cities in the city table with populations larger than 100,000. So I think that's a select city from select all columns. Select all columns for, so select all from city where country code is equal to USA and population is greater than 100,000, I think. I'm not sure. And we're doing MySQL. So let's run it. Runtime error. You have an error in the SQL. Check the manual corresponds. You use near population. Where is it? There we go. So the issue was I put 2 equal signs instead of 1. So as you can see, select all from city. So select all columns from city where the country code is USA and the population is equal to 100,000. So that's revising the select query number 1. So we just submit our code. And we're off to the next challenge. So this one, we're supposed to query the name field for all American cities in the city table where the population is larger than 120,000. The country code for America is USA. So it's the same one. So that's just a simple select name from city where population is greater than 120,000 and the country code is equal to USA, and that should be the answer. So let's run the code, and there we go. So we submit it. We're going to the next one. Next challenge. So in the next challenge, we're doing the basic select all. So we're supposed to query all columns for every row in the city table. So that's just select star for city. And that should do it. So we run the code. And that is wrong. So city, select all from city. And then there we go, and that would just give us every column in the table. Submit the code. Next challenge, where the next challenge is query all columns for city in the city table with the ID 1661. So query all columns for a city in the city table. So that's a select star from city where ID is equal to 1661, I think. And then let's run that one. And there we go. So that's select by ID. So submit that. Then we're off to the next challenge. Next challenge is the Japanese cities attributes. So query all attributes of every Japanese city in the city table. The country code for Japan is JPN. So query all attributes, so all columns for every Japanese city. So I think that's a select all from city where country code is equal to JPN. I think, I'm not sure. So, and there we go. And that's Japanese cities attributes. So we submit that one. Moving on to the next challenge where we're doing Japanese city names. So we're to query the names of all Japanese cities in the city table. So query the names of all Japanese city in the city table. So again, that's just gonna be a select name from city where the country code is equal to JPN. And then we run the code and submit it. Oh, I click submit twice. So then after the next challenge, so this one is the weather observation station. So we're supposed to query a list of city and states from the station table. Query a list of city and state from the station table. Station table is described as follows. The schema, so what we need just the city and the states. So I think that's gonna be a select. What's going on here? Select city. Select city and then comma state from the station table, semicolon, and let's see. Yeah, you don't need the semicolon, but it's a good practice to have it. So submit the code and we're good to go. Moving on to the next challenge, we have the weather observation station 3. So this is where we're to query a list of city names from the station table for the cities that have an ID number, that have an even ID number. Print the results in any order but exclude duplicates from the answer. So what we have to do is we have to select a list of city names. So select city from station. So that's the first part, right? But I think what we need to do is we have to select a distinct, because we don't want them to have duplicate IDs. So station for cities that have an ID number. So where ID, it needs to be even, so it needs to be divisible by 2. I'm not sure how that would work. I'm not sure if this is the correct thing, so let's run it. All right, so that's wrong. So let's do where even SQL select. So simplest way to fetch rows with even or odd numbers is to divide the column by 2 and check the remainder. So what's the proper syntax? From my table, we're mod. This is MySQL Postgres. Where ID. So let's try this piece of code right here. Let's try this right here. So let's do where, and then the my column is ID, and let's check it. And it works. So that's, we don't know the answer, so we went and go find it. Well, we knew how the principle, but I didn't know the correct syntax. So it's mod ID divided, and then it takes the, the divided number, and then the remainder is 0. So that means it's an even number. So anyways, weather observation station 3, and let's submit that code. Congrats, you earned your first star. And then let's move on to the next challenge. So this one now we're supposed to find, we're doing the weather observation station 4. We're supposed to find the difference between the total number of city entries in the city table and the number of distinct city entries in the city table. So what we have to do is we have to select the count of city, right? And then we also need the count of the distinct city, and then let's call it as diff, I guess. And then from station, and let's see if this one works. There we go, and the answer is 13. So it says find the difference between the total number of city entries, so that's the select count of every city, and then we do a subtract in the select, and then we get the count of the distinct cities, and then we have to give it a name, so then that way when the output is print, that would be the header, so it'd be as diff from the station table. Submit our code. On to the next challenge. So the next one, we're supposed to query the 2 cities in the station with the shortest and the longest city names, as well as their respective lengths, i.e. number of the characters in the name. If there is more than one smallest or largest city, choose the one that comes first when ordered alphabetically. The sample output is, for example, city has 4 entries, D, E, F, A, B, C, P, Q, R, S, X, Y, Z. So the sample output would be ABC, which has 3 characters, and then PQRS, which has 4. As explained, when ordered alphabetically, the city names are listed A, B, C, D, E, F, G, whatever, with the lengths 3, 3, 4, 3. The longest name is PQRS, but there are 3 options for the shortest name. City, choose ABC because it is the first alphabetical. You can write 2 separate queries to get desired output. It need not be a single query. So let's do select city and then get the length, the length of city. So I guess that would give us the length of the characters as car length. Let's call it length, I think. Yeah. And then from station, and then we order by order by char length, and then city, and then we limit it to 1. So what I'm doing, I'm selecting the cities, and then I'm selecting the length of the cities, and then naming that column char length from the station table, and then I'm gonna order by the character length first, and then the city. So then that would give me the one with the lowest, and the lowest, because then it would be ascending, and then the limit would be 1. So that's the first one. And then it is the same exact query, but we're ordering by the character length in descending order. So then that would give us the longest length in theory. So let's run it. Error. You have an error in here, so you could check the manual as corresponding to that. Limit 1. So what's the issue? So it says you have an error in your SQL syntax. Check the manual that corresponds to your MySQL server version for the right syntax to use. So let's see something. So let me do this, and let me run the code. Still wrong. So that wasn't the issue. Alright, that limit. Let's see something. Cut that. Run that. Let's see. Alright, by that. Let's copy this, and then let's do DSCN, and then let's run the code. Okay, so the issue was, what was the damn issue? The issue is I had a comma after the word city. So if you look at it, let me put it back. That was the issue. No commas. So if you run the code, then it works. So we're selecting the city, and then we select the city length, and then as character length from station, order by length of the city, city limit 1. Boom. And then we just submit. So we're supposed to query the list of city names starting with the vowels A, E, I, O, U from station. Your result cannot contain duplicates. So enter your query here, follow these instructions. That's DB2, don't need that. So enter there. Okay, so this one is a select distinct, where, so let's, I think it's a select distinct city distinct city from station. Where is it? Where city like. How do you do it again? I think it's a like, and then you say where it starts. All right, so let's do select where starts with. So to query any so select query to find the name of a person whose name start with a specific letter. Here is blah blah, use geeks, yada yada yada. This is the table. Add to the value. Then we need to select from data. Now let's find a person whose name start with the specified letter, where, like, pattern. So I'm on the right track. So it's, there we go. How do I do it with multiples? So if it's like, like a, comma, Okay, so we're gonna brute force it. I know there is a more efficient way, but we're gonna brute force it. So what I'm gonna do is I'm gonna do R. That should be enough. And then we're city like, let's do that. So we're city like, boom, 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 boom. So it's where city like A, E, I, O, U. And then it's the exact same thing. IOU, except it's A, E, I, O, copy that, U. So we're selecting the distinct city from the station table, where the city is like, it starts with a A, or it starts with a E, I, O, R, U, but these are just commas. It just works with common lowercase, and then we have to do the same for A, E, I, O, U in uppercase. It's not the most efficient type of way to write it. You could probably do some farmer regex or something, but I don't want to have to figure out how to do that. So let's run it and see if it works. And it is completely incorrect. So wrong answer. My output is, oh, I have these the wrong place. So it ends with the percentage sign. So percentage. And as you can see how frustrating this process is. So like I said, not the best way to do it, but, and there you go. So these are all cities that start with vowels. So you can imagine that it would be very, very annoying if you had some complex SQL to write and you had to do it like this. So not efficient, but it gets the job done. So let's submit it. So code submitted. On to the next challenge. So now we have to query the list of city names ending with the vowels A-I-O-U. Your results cannot contain duplicates. So it was the same exact one. Actually, it was our first solution for the last question that we did. So it is select distinct city from station where city is like, and then it's gonna be that, and it's gonna be a with the percentage sign, or, and then let's just copy it 1 2 3 4 5, copy 9 more times. So 1 2 3 4 5 6 7 8 9. So this one we won't need you here. A E I O U, and then lowercase a, lowercase e, lowercase I, lowercase o, and then lowercase u. And let's see. You have an error in your signature. Oh. These? No, these don't need. Oh, city. Where? City. Or in the city. So now this is redundant code, but it works fine right now. And then we submit the code. On to the next challenge. So we're supposed to query a list of city names from the station which have vowels A, E, I, O, U as both their first and last characters. So let's bring that back to my SQL, and this one's gonna be select all. No. Select city from station where city is like, and this one is a, which have vowels A as both their first and last characters. So it has to be both. So I think this one is begins with, I think it's, or like city is like A and A. And let's just test this query out. So this is, let's just test out, see what works. Like, they didn't give us any output. Or city like, okay, so this is how it would look where city like A and it ends and starts with A. Now I could do this entire thing ten times, but it would be mad annoying. So I'm gonna have to figure out how to streamline it. So let's select where beginning and end of a string. For wildcard, select ID name AB %K. Where clause is like keyword that allows you filter columns that match the wildcard. Questions about list of special characters. It's like looking for blah blah blah. Okay. So then that means what I could do is I could do it like this, and I'd still get the same result right here. So let's check it out. Yes, but this is not the most efficient either, but I'll take it. I will take it. So that's gonna be a or where city like that. So it's AE I O O U AEIOU, then common A, common E, common I, O U, boom. Get rid of this one, and then let's see what happens. Incorrect. Okay, so it needs to be a distinct. Still wrong. Oh, U. Still incorrect. And why is that so? Select distinct city where AEIOU. City names of station would have vowels as both their first and last name. Your results can't contain duplicates. Fail to see the issue here. Oh, I get it. So my way is completely incorrect because it's gonna be it'll only pull A and A, but if it starts with an A and ends with an E, I won't get that. So I'm gonna have to figure out an either. So let's see. Let's do follows. Da, 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 da. Select station. Regular expression. No, this syntax is in MySQL, so oh, this is actually the answer for it too. Huh. Microsoft SQL Server. Yeah, so it looks like it's regex is the way to go. I don't know what this R like is. R like is used to perform pattern match on a string against a pattern. Pattern you want to match against da 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 da. Any uppercase letter, any lowercase letter. So I guess you put it in there. I don't know what these mean. Any single character, 0 or more instances of a string preceding it. That's just one of those things where okay, so I guess it doesn't like, let's use where city, let's run that, and there we go. So now you get the ones that have various different letters at the beginning of the end. So this is the more efficient way to do it. I just had to Stack Overflow it. I don't really understand the regex, but you know, we don't have to reinvent the wheel, so we just Google it, figure it out. So submit the code. So we selected the distinct cities from the station where the city had this, where it's using R like, so and so. Let's see if it uses like though. It doesn't use like. So when using the regex, you have to use the R like. So I submit it. And that's that. Off to the next chapter. So query the list of city names from station that do not start with vowels. Your results cannot contain duplicates. So that do not start with vowels. It's the same select query that we just did, but it's the opposite. So let's try something. So it's select distinct city from station, right? Where city, and then we're gonna come back here. We're gonna get this. I'm gonna paste it here, but I'm looking for a not like instead of an R like. So not R like SQL, something similar. Okay, so it would be, okay, so let's put the not in front of it and see if it helps us. Let's run the code, and it does not work. Your results cannot contain duplicates from stations. I mean, it looks right. Oh no, it starts with some here. Not. Ha 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 ha. Oh, this is just where it doesn't start with vowels. Okay. So what's the regex for it? Characters not used in between the square brackets. Match uppercase. Da 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 da. Let's try. Hold on. See if I can understand this. One or more instant preceding it. End of string. So let's just do this portion right here. Let me see what that star mean. Caret matches beginning of the string. Okay, so let's remove this. I don't know if it'll work. Ha! And it worked. So that's what it is. So regex it out. I mean, you could do it the way that I did it, using the like A, like O, like U, that long way. But this works. So let's submit it. And then next challenge, which would be the opposite, I believe. So, query the list of city names from the station that do not end with vowels. So, select distinct city from station where city not or like, and then I'm gonna go on a limb here and do this piece right here, and let's see what we get. And it worked. Ha ha ha. All right, so based on my understanding, so this is where this is where it begins it. I think this whatever you call this symbol right here denotes the beginning of the string, and then these last, let's see, the period and the star means any single character, and the star means 0 or more instances of string preceding it. I don't know what it means, but this right here denotes the end of the string. So I don't know. Let's submit the code. Congrats, you have earned your second star. Let's continue. The next challenge, MySQL, query the list of the station that do not start with the vowels or do not end with the vowels. So that's really this entire thing. And then it would be not right there. And that should be it. So select the distinct city from the station table where the city is not like this regular expression. And there you go. Submit that. On to the next chapter. So this one we're doing weather observation 12. We're supposed to query the list of city names from station that do not start with a vowel and do not end with a vowel. So it's either or. Is it? It can't start with a vowel and it can't end with a vowel. Right? So this one is select distinct city from station where city not are like, and then we need our regex. So we need the entire thing, but we're not like, and so it's an and city not are like. So I think the first ones were or, and this is an and that's your answer right here. Submit and go through. Then we're on the next challenge. So now we're working with other stuff. So we're supposed to query the name of student in students who scored higher than 75 marks. We're supposed to order your output by the last 3 characters of each name. If 2 or more students both have the names ending with the last 3 characters, Bobby, Robbie, secondary, sort them by ID. So we're supposed to select the name from the students where marks is greater than 75. So the issue now is to get the last 3 characters of each name. So how do I get that? Last 3 of a string in SQL, right? So extract 3 characters from the string starting from the right, and that's select the right SQL tutorial 3 as the exact string. So okay, so it's gonna be this right here. So comma right, and then name, and then 3, and then order by the output of the last name. So it's a order by the as current th. So let's order by current and then order by ID. And then I'm pretty sure this is wrong. So I'd probably have to get Let's run it. Yeah, it's wrong. So my output was Stuart Art, yada yada. So we're getting it, but we just need a name. So my sample output should be ID, Ashley, and the marks, right? So let's do this is my sample input. My sample output should be name. So select the name. And then let's order by that. Not by that. Oh, it worked. Ha ha ha. So select the name from students where the marks is greater than 75. We're ordering by, and then we collect the the name. So we're getting the we're selecting from the right the three strings. So we're ordering by that, and then we're ordering by the ID in ascending secondary. So that worked out fine. Submit. Okey-doke. And then we're on to the next one where we're doing employee names. So we're supposed to write a query that prints the list of employee names, i.e. the name attribute, I guess, from the employee table in the alphabetical order. So write a query that prints the list of employee names. So select name from employee table. Order by name. So it's an order by name. Oh, where employee ID is employee ID number, name is their name, months is their months, they've been working in the company staff. Okay, so that was the relevant information. Let's see. Yeah. So there's a basic select name from employee, order by name, or we can order by one. Yeah, so either way. Next challenge, basic select employee salaries. So we're doing the employee salaries. So we write a query that prints a list of employee names for the employees in the employee table having a salary greater than 2,000 per month who have been employees for less than 10 months. Sort your result by ascending by employee ID. So we're supposed to select the names. Select the name from employee where salary is greater than 2,000 and months is less than 10. Then we're gonna order by employee ID. Let's see. Wrong. Your output, no output. Okay. Okay, so we selected the names of the employees from the employee table where their salary was greater than 2,000 and they were there for less than 10 months, and then we order by the employee ID. So when you don't have to put ascending unless you need it by descending, I believe. Congrats, you have solved all the basic select challenges. So next, what we're doing is the pads question. So what we're supposed to do is we're supposed to generate the following two result sets. Query an alphabetically ordered list of all names and occupations, immediately followed by the first letter of each profession as a parenthetical. For example, an actor name A, a doctor name D, etc. And then after that, we're supposed to query the number of occurrences of each occupation in the occupation, sort the occurrences in ascending order, and then output in the following format. So there's a total of occupation, count occupation. So it's supposed to look like this. So first things first, I know that I need a select on the name, right? Select on the name, and then I need a select on this right here. Occupation, 1, and then as from occupations, and then I'm supposed to order by name. So if I do that, it's not gonna be right, but I'm gonna get a visual representation. So we know that Amina is a doctor, Ashley is a professor, Belvet is a professor, Brittany is a professor. So what I need to do is I need to concatenate those two into one. So what I'm gonna do is I'm gonna do a concat, open the concat, and then close it right here, right? And so I'm concatenating name with this right here, right? And where I'm concatenating it with the open bracket, and then comma, close it on the close bracket. So basically, calling the concat, let's pull it up. Concat Sql. So it takes one input and then two, and then if we concatenate it together, it would give us both of them. But if you want something in between it, then we just basically put it in. So SQL space is space fun, and that would give us what we want. So all we gotta do is name, open bracket, open bracket, this right here, close the bracket, from occupations, and then order by name. And then I'm gonna call it as name, and then order by name, and then we'll run it. And then as you can see, it's now concatenated, right? So now we need to do the other part of it where it is gonna be the string right here. There are a total of XYZ doctors. So then what I can do is I can do a select, and then I'm gonna do a concat again, and then open boom, and then it's gonna be there are a total of, right? Close it, open it again, something's gonna be in here. So close it, space, and then we're gonna do count occupation, and then it's gonna be space again, lower occupations, occupation, comma, S full stop as profession from occupations, and it's grouped by occupation, order by profession. Close it right here. Do that right there. So select the concat. So this is where we select all of this. And then now we need another select statement where we concat. There are a total of space, the count of the occupations. Space again. And then the occupation. And S as professions. This whole thing is from as profession. And then from the occupations table, and then we group it by the occupation, and then we order by the profession. And this should run. So we have an issue. We're not getting any. Let's put back this right here. So select concat. There are a total of space, count of the occupation, space again, occupation, full stop as profession from occupations, group by the occupation, order by the profession. So let's run it. There we go. So the issue was the semicolon right here. So let's go over it again. So select the so we're supposed to concatenate the name with a bracket, the letter as the name from. You get the gist. Submit it, and that's our code. And then, so query account of the number of cities in city having a population larger than 100,000. So query the count. So it's select the count. Of cities. I'm not sure if count should have a bracket. Let's see. Count MySQL. Yeah, so it's a function, so it takes an input. So it's select the count of cities from city where population is greater than 100,000. Six. So query a count of the number of cities I didn't have any output. CITIES. Name. There we go. And that's why you gotta look, you gotta really understand the problem properly, because I wrote cities and there's no cities, it's name. Submit. We're good to go. So we're off the next challenge, but let me just enter it from here. So MySQL, so query the total population of all cities in city where the district is California. So it's a select the total of cities, so that's a sum of query the total population, so population of all cities where population from city where country code is equal to, no, not country code, district, where district is equal to California. Let's see. Yep. Now we have 339,002. Query the total population of cities in the city table where district is California. All right. So submit. So now we're on to the next one where we're revising aggregations, which is averages. So query the average population of the cities in city table where district is California. So select average population of cities. So I don't know if it's AVG. Yeah, it looks like it's AVG, or population from cities, city where district is equal to California. And then let's run that. We're good to go. Submit. Yeah. On to the next one. So aggregation, we're doing aggregation average population. So we're doing query the average population for all cities in city, rounded down to the nearest integer. All right, so that's select AVG population for all cities from city. Now I need rounded down to the nearest integer. So let's do average products, blah blah, yada. That's all it does. Around 2 decimal places. So I'm thinking something like this. I think my output is boom. So then what's an integer? A whole number? There we go. So we wrap the average function in the round function and we determine the amount of spaces that we want to round it down to. So submit the code and on to the next challenge. So we're supposed to query the sum of the populations for all Japanese cities in the city table. The country code for Japan is, so it's select the sum of the population from city where the country code is equal to JPN, perhaps? Nope. Very incorrect. From the city where, haha, where is they? Let's run that. There we go. Submitted. So next challenge, still on aggregation, query the difference between the maximum and the minimum populations in the city. So it's a select max, boom, population, query the difference between the maximum and minimum populations in the city. So query them, select the max minus the min population as, I don't know, pop from city. I'm not sure, I'm guessing with this one. Oh, and I was right. Submit it. Next challenge. So we're doing the aggregation question, the blunder. So Samantha was tasked with calculating the average monthly salaries for all employees in the employee table, but did not realize that her parentheses buttons were broken. So until after completed the calculation, she wants your help finding the difference between her miscalculations using the salaries with any zeros removed and the actual salaries. Write a query calculating the amount of errors, which is the actual average minus the miscalculated average. Constraint is salaries is greater than 1,000, less than 10 to the 5th. So this is sample output. This is what's in the actual table, but as you can see, she's replaced all of the zeros, right? So basically, to calculate the difference is, first we need to get the average, that the proper thing that she was supposed to do, which would have been salary. So the average salary from the what's it called, the employees table, from employees. So now, but what she did was she calculated the average of, but she replaced the salary. So basically what I have to make the mistake that she did, which is replace all the zeros with an open space, I guess. So replace the salary, and it takes what you're gonna replace with what you want to replace it with, which would be just an empty space. So average of the replaced salary. So we're doing the mistake that she did, right? So let's say if with this, if I print this, it should give me this this output down here, right? So let's run the code. Well, I guess not, but that's the average that it gave us. But if I do this and then wrap it in a ceiling and then close that, let's run it. we got the answer 2,253. All right, because we had to round it too. So submit that. That's the answer. So next question is top earners. The question goes, we define the employee's total earnings to be their monthly salary times the month's work, and the maximum total earnings to be the maximum total earnings for any employee in the employee table. So we're writing a query to find the maximum total earnings for all employees, as well as the total number of employees who have maximum total earnings. Then print these two values as two space-separated integers. So write a query to find the maximum total earnings for all employees, as well as the total number of employees who have maximum total earnings. So if you say the maximum earnings value is 69,000, the only employee with earnings equal to that is Kimberly. So we print the maximum earnings value, and then we count the number of employees who have earned that much. So what that means is we need to select, and then we need to calculate the total earnings. So it's months times salary, and we can add that as earnings, and then we get the count, right? Then we count all, right, from the employee table. So then what we need to do is where months times salary is now equal, so is a subselect, so the is now equal to the select of the max month times salary as, let's call it max earnings from the employee table. Then we just need to group by the earnings. So select salary. So we calculate, we do months times salary, months times salary, months times salary, months times salary. We calculate that, right? And then that will be giving us the totals over here. Earnings, boom, 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 boom. All right. And then we get the counts. We get the count, right, from the employee. So now where this, right, is equal to, so let's say where earnings is equal to the maximum value that is calculated, that we'd be getting right here, the maximum value, where the earnings is equal to that, then we just count it and group by earnings. So let's run it. I'm still not getting the table. Doesn't exist. What doesn't exist? At line 5, Select as earnings, count all from employee. Months times salary. Months. Okay. Is it because I did it like that? Run this does not exist. What? Where select? Count all. It's the V. There we go. So I didn't even have to do that. Let's put it back. Place them right here. So I guess it wouldn't work. So let's run it again. And submit the code. So alright, now we're gonna let's do weather observation station 2. So let's see what this one's asking us. So we're to query the following two values from the station table: the sum of the values in the lat north and in lat north rounded to the scale of 2 decimal places, the sum of the values in long W rounded to 2 decimal places. Where lat n is the northern latitude and western longitude. Our results should match this form, lat long. So let's see, the sum of the values in lat n and then the sum of the values in long W. So I think that's gonna be a select star. No, not select star. Select the sum of lat n, comma, sum of long W, from station. It shouldn't work though. Okay, so see, it's supposed to be rounded to 2 decimal places, so I think that's gonna be around, comma, 2, and then round, comma, 2. So let's see. There we go. So select the sum of all the latitudes and then round it to 2 decimal places. Select the sum of all the longitudes, round it for 2 spaces from station, and that's it. So let's submit it. Congratulations, next challenge. So we're doing weather observation 13 now. Let's see. So now we're doing weather observation station 13, where we're supposed to query the sum of northern latitudes from the station having values greater than 38.7880 and less than 137.2345, and we're truncate to your 4 decimal places. So I think it's gonna be a select, and then that's gonna be a round, and then we're gonna sum it, and then that's gonna be lat n, and then to 4 decimal places from station where lat n is between 38.7880 and 137.2345. And let's see how that works. There we go. So select the round sum that's rounded by 4 decimal places from the station where the north latitude is between this figure and this figure. Submit. Next challenge. Now we're at weather observation station 14, where we're to query the greatest value of the north latitudes from the station that is less than this value. So I think this is select the max, well, the rounded max actually, the max latitude, bracket, the rounded by 4 decimal places from station where lat n is less than 137.2345. And then let's see if this works. And there you go. So select the rounded max, and it's rounded to 4 decimal places from station where the north latitude is less than this figure. Submit. There we go. Next challenge. So we're supposed to query the western longitude for the largest northern latitude in the station that is less than 137.2345, and then round it to the nearest. So to find the largest latitude, which is less than 137.235, we'd have to order it by the latitude in descending order. So it'll be select round long underscore w, comma 4, right? From station, well, let's do it like this. From station where the lat n, right, is less than 137.2345, and we'd order by the Latin in DESC limit, and then we limit it by 1. And that should suffice. Still incorrect. Incorrect. There we go. Submit. And on to the next one. So we're supposed to query the smallest northern latitude from the station that is greater than such. So select the lat n from station where lat n is greater than 38.7780. Select the smallest northern latitude that is greater. So let's see if I can use min, and then I can also round it by 4. Let's see how this one plays. Okay, so that's wrong. From station where lat n is there we go. SQL is kind of like English, so it kind of messes me up sometimes. And submit it. And we're good to go. MySQL. So query the western longitude where the smallest northern latitude in station is greater than 38.77. So it's just like the one that we did. So it's select the round of the long underscore w comma 4 from station where the lat n is greater than 38.7780, order by lat n, and then in descending, and then limit 1. So select the round from the station where the latitude is less than that. So let's see where lat n is greater than this figure right here. So, and then order by lat n, and then limit it to 1. Let's see if that works. Yes, because it's greater than this, so it'll give me all of them. But I want the smallest. I want the smallest latitude of the greater. Okay, all right. Submit. On to the next one. So we're supposed to consider P1, which is A and B, P2, which is C and D, to be 2 points on a 2D plane. A happens to be equal to the minimum value of the northern latitude. B happens to be equal to the minimum value of the western longitude. C happens to be the maximum value of the northern latitude. D happens to be equal to the maximum value of the western longitude. So we're supposed to query the Manhattan distance between P1 and P2 and round it to 4 decimal places. So what is the Manhattan distance? It's in a plane where P1 at x1 and y1 and P2 at X2 and Y2. So it is the absolute value of X1 minus X2 plus Y1 minus Y2. So X1 minus X2, X1 minus X2 plus Y1 minus Y2. So what we have to do is we have to select and then we have to round. And then after we round, we have to get the absolute value of the maximum, which is X1, which in our case would be A, would it? Maximum value of the, so it's supposed to be X1 and X2, which should be A minus C. All right, A minus C, and then it would be B minus D. So let's do the maximum value of lat n. Well, it's the minimum, but it shouldn't matter because it's absolute value regardless. So let's do A, which is the minimum value of the long. So minimum long n, right? And then minus the maximum value of long n. I think, yes. And then it's gonna be plus. So plus the absolute value of the minimum of, well, actually no, it's lat. So it's lat n, and then long w minimum minus the minimum long w again, and then we should have two parentheses to close it, but before that we have to set, there we go, so I can bring it back down here, and then it would be from station. So select, so we have to round it first, and then within it we have our absolute value of x1 minus x2 plus the absolute value of y1 minus y2. And it is incorrect. Why is it incorrect, you may ask? The absolute value of this whole thing right here. Oh, it's max. There we go. So I had min twice. Submit it, and we're good to go. Continue. Next challenge. weather observation station 19. So consider P1AC, P2BD to be 2 points on a 2D plane where A and B are respective minimum and maximum values and of northern latitude, and C and D are respective minimum maximum values. Query this distance, which is it this? So I'm guessing we're using the square root. Which one? So I'm guessing we're using this formula right here, where it is Q1 minus P1 to the power of 2 plus Q2 minus P2 to the power of 2. So I'm guessing it'll be longitude, maximum longitude, minimum longitude to the power of 2 plus maximum latitude plus minimum latitude to the power of 2 under the square root. So how does one write that in SQL? So we have to select the round and then get the square root by the power of the maximum latitude of n subtracted from the minimum latitude of n to the power of 2, and then plus the power of the maximum longitude of w minus the minimum longitude of w, and then to the power of 2 again, rounded to 4 from station. That one was kind of complicated, so basically we sequelized this right here. So maximum latitude minus minimum latitude to the power of 2 plus minimum maximum longitude minus minimum longitude to the power of 2, and then find the square root. So round it by 4 first and then put it all in the square root function, which is this entire thing right here, and then this entire thing right here, and then raise this entire thing to the power of 2. So maximum latitude minus the minimum latitude plus maximum longitude minus the minimum longitude, raised it to the power of 2. All right, submit it. And we're good to go. So let's go on to the next challenge. So doing population census. So given the city and the country tables, query the sum of populations of all cities where the continent is Asia. And that's gonna be a join. So we're gonna do is select the sum of city dot population from city, and then we're gonna join the country join the country as CO on city dot country code equal CO dot code where continent, I think so, is equal to Asia. So select the sum of some, let's call it, of CI city as CI where join country as CO on CI.country code. Alright, yes, so makes sense now. So we're gonna call city CI and we're gonna call country CO. So we're selecting the sum of the CI population from the CI table, and then we're gonna join country as CO on the country code. So country code in city over here is equal to the code over there, and then where the continent is Asia. So let's run it. There we go. Submit. Next. So we have another join, basic join. This one's African cities. So given the city and country tables, query the names of all cities where continent is Africa. So city.country code and country.code are matching key columns. So select CI dot name from city as CI. We're gonna join country as CO on CI.country code. Same. And then equal country.code. So join it on country code equal, join it on country.code, join country as CO on CI.country code equal CO.code. And then where the continent is equal to Africa. Boom. Submit. Next challenge. Average population of each continent. So given the city and the country tables, query the names of all continents and their respective average city populations. Rounded to the nearest integer. So, given the city, query the names of all the continents and their population. So what I need is, I need CO.continent. I need CO.continent, and I need the floor AVG of VG of CI dot population from country as CO where co.code is equal to ci dot country code, and then group by co dot continent. Join country as join city as ci on ci. Let's see. Boom. So select the continent and the average population. From country as CO, join city as CI, and the country code is equal to, Run and submit. There we go. So this one is write a query identifying the type of each record in the triangles table using its 3 side lengths. Output one of the following statements for each of the records. So it's equilateral if the triangle has 3 equal sides, isosceles if only 2 sides are equal, and scalene if none of them are equal. And not a triangle, the given values of A and B don't form a triangle, sorry. So to do this one, we're gonna use a case statement. So we're gonna do select, and we're gonna do case, and then when A plus B is less than or equal to C, or B plus C is less than or B plus C is less than or equal to A, or A plus C is less than or equal to B, then not a triangle. And then when A is equal to B and B is equal to C, then equilateral, I think that's how it's spelled. And then when A is equal to B, or B is equal to C, or C is equal to A, then I saw some leaves. And then it'll be an else scalene, then we'd end the case, and then from triangles. So basically it runs through these one by one. So first it detects if it's a triangle or not. So when A plus B is less than or equal to C, let's see. Values in the tuple 13 plus 14 and 30 cannot form a triangle because the combined values of sides A and B is not larger than one of the sides of C. So if A plus B is still less than C, or if B plus C is still less than A, or A plus C is still less than B, then it's not a triangle. But then, so then it sees if it's equilateral. So if A and B are equal, and then B and C are also equal, then it's an equilateral. Then if A is equal to B, or B is equal to C, or C is equal to A, as long as two sides are equal, then it's an isosceles. Else, if none of the other cases fit, then it's a scaling. And then we end, and then we're selecting from triangles. So run. And it is wrong. Why is it wrong? My output. A plus B is less than C. Is it because I have less than's in there? A and B and C equilateral. AB or BC or CA isosceles. Else scaling, maybe it's not spelled properly. Equilateral. That's right, not a triangle. Is it case? Is it a case issue? It was a case issue. Ha! And there we go. Submit. And then boom. So that being said, we have now completed all of the basic SQL skills questions. So if you look in there, there's none unsolved. So all we need to do now is do the intermediate questions. And that's it for this video. Thank you for sticking around. I know it's probably gonna be a long one, but if you like the video, do like, comment, share, and subscribe. Catch you in the next one when we're tackling the SQL intermediate. Catch you in the next one. Peace.